Uh, Good morning, everyone. So, I'm starting.
Yes, Amit, give me 2 minutes.
Yes, yes, sir.
14 have joined. Oh, Sharmila, ma'am, we can get started.
Yes, teacher. Yes.
Okay, ma'am, sure. Fine. Yes, Amit.
Good morning, everyone. For today's session, we have Kumar, who has 20 years of veteran in IBM, New York. He has also developed a large-scale analytics and messaging platform for cooperative bank and fintech. Professor Kumar is also a founder of printing startup in 2016. About his qualification, he has done BS, MS, and MBA from Columbia University in New York. Professor Kumar has 3 patents and 24 invention disclosure. Last but not the least, he's also a co-investor in Hedge Fund and professor at NJIT. Let's have Professor Kumar Mani.
Thank you, Amit, for that gracious introduction, and good morning to everyone at Vivekanand or VESIT. I hope everyone is doing fine.
Yes, sir, we are. Thank you
Good.
so much for joining. Yeah.
Sure. Can everyone hear me okay? I just want to make sure that everyone's able to hear me fine.
Yes, sir,
Yes,
you're
sir.
audible.
Okay, fantastic. So that's me saying hello. I'm going to turn off video and switch to audio plus slides. Okay, so. Okay, let me see if I can share my. So hopefully you should be able to see my my presentation.
Yes, sir, it's visible.
Okay. And again, Richard, I'm going to make this available to anyone who wants a PDF version that you can socialize to the attendees. Okay.
Sure, sir. Thank you so much.
Okay. Great. So let's go ahead and get started. Again, I'm Professor Kumar from the New Jersey Institute of Technology. It's great to be here. First and foremost, I want to bring my greetings to all of you in Amchi, Mumbai. And I hope everyone is doing well as can be given the current COVID pandemic. Just stay safe, get vaccinated, and make sure that you take precautions as we try to navigate this pandemic. Okay, so the title for today's talk is Fauda Jugaad, which is really about new methods in teaching. And this is a work in progress. So when the research forum faculty and the IQAC folks reached out to me, I was in a bit of a quandary because normally we present sort of research topics, and that's been the type of thing that I've been presenting to some of the other colleges that we work with. But what I thought we would do is to present something that's topical, meaning something that's relevant in today's environment, particularly as we go through this COVID pandemic and so on. So I'll go through this talk. The outline is going to be, I'll probably speak for about 40 minutes or so, 35, 40 minutes probably. And then, Richard, perhaps you and some of your colleagues can moderate a little bit of a Q&A session for folks that have questions.
Sure, sir.
Okay. So the title for my talk is Fauda Jugaad, and it's reflective of the times that we're in. And then this is the agenda. So we're going to do some definitions, right? What's Fauda mean? What's Jugaad mean? And you know what we were facing here in terms of COVID and so forth. And then I'll give you some context around the problem that I'm trying to solve here. And then we'll talk a little bit about Jugaad, which is the solution that we had to come up with in fairly short time frame. And then we'll have some time for Q&A. So the talk is tilted towards those of you who are teaching computer networking, So Richard, I'm not, is the faculty here all sort of computer science, computer engineering, information technology type faculty, or do we also have faculty from other branches of
So we have from other
VES?
branches as well, but mostly 70 to 80% of the faculties that are here right now in the meet, they are from computer science background, and they have quite a good knowledge about computer networks.
Fantastic, great. And so some of the talk has to do with a technical system called NS3. And so perhaps some of you have some exposure or experience with NS3. So some of it might be stuff that you've seen before, but the context of it and the rest of it is probably helpful to you. Richard, to your knowledge, do you use NS3 in VES?
So
Some of the faculty use it.
we use NS2 and GNS3 we have been using, the graphical one, GNS3.
Excellent, excellent,
Yeah.
excellent. Okay, great. So let's talk about Fauda, Jugaad, and COVID. So we'll start with some definitions, right? So what's Fauda? Some of you probably are familiar with Fauda, which is the Israeli web series that became popular 3 or 4 years ago. The word Fauda means chaos. It's a Hebrew word, and it just means chaos. And then, of course, the word Jugaad, that most of us are familiar with Jugaad. What I was surprised, pleasantly so, to discover was that Jugaad is now an official English word. It's part of the Oxford Dictionary in 2017. It means a flexible approach to problem solving that uses limited resources in innovative ways. And then, of course, we all know what COVID is and so on and so forth, right? So what's the context of this talk? The context of this talk is a trifecta, which is a perfect storm that hit my institution, NJIT, as well as a bunch of other colleges in the United States, which is chaos in terms of the number of students that suddenly spiked. And then there's the COVID pandemic, with which a lot of students couldn't really come to the United States the way they normally would, and so they had to do classes and such from their home country and so on. And then because of the non-availability of test centers, we were the GRE exams couldn't take place, and so we had to make a bunch of admissions and other types of enrollment decisions without some analytical data points. So these three things led to, for NJIT anyway, a spike in the number of students coming in. Right, so this is not ordinary for us, meaning for folks in the United States, but in India, a Fauda type of chaos is not new, right? So whether it's for the Covaxin and the Covishield, or whether it's for hospital beds or whatever else it is, and it's certainly not new to the world, right? Last couple of years, the world has seen some significant and unexpected stresses on the medical systems, the population systems, and the care delivery systems worldwide. And so we've seen these things happen, and it's spikes that we haven't seen before, right? So how do we deal with this? To expand on this context, right? So NJIT, for those of you that might not be familiar, right? So we're a very thick urban campus, right? So unlike many US universities, which are land grant schools, right? So if you take the University of California or the University of Massachusetts or University of Virginia and so on. So they're on large campuses. And certainly there's some institutions in India, for example, IIT Kharagpur, IIT Kanpur, etc., are on fairly large campuses. But NJIT is kind of like VJTI in Mumbai, right? Perhaps Vivekananda in Mumbai as well, but it's kind of like VJTI in Mumbai, where it's an urban campus, and so space expansion is very difficult, right? So enrollment keeps growing, and we're almost always bursting at the seams, trying to expand, put up new buildings, and try to look for other ways in which we can expand. Within NJIT, we have what's called the Ying Wu College of Computing, in which I teach. And this college obviously delivers MTech equivalent or MS programs in computer science, information systems, informatics, data science, and so on. In NJIT, we have about 18 different computer labs, a total of about 1,000 or so computers or workstations. Yeah, that's Windows workstations, Linux workstations, a bunch of other workstations. But these are not for YWCC use alone, right? They're for the broad NJIT use. And NJIT, like VJTI, is a omni engineering campus, right? So NJIT has a College of Engineering that offers programs in electrical, computer engineering, civil, chemical, mechanical. And we also have an accredited College of Architecture, right? So they have their own design school and stuff like that. And so a lot of these computers have some fairly specialized and also expensive software licenses on them for things like AutoCAD and PSpice for electrical modeling and such, and PCAD for space modeling and such, and a couple of other packages. Right, so there's a lot of competition in the existing computer labs for students to be able to do some work. And of course, you guys know this as educators here, right? So a lot of students bring their own laptops, but they end up connecting remotely to these labs to be able to use some of the specialized software, right? So Mathematica, Wolfram, and so on, for which NJIT spent a lot of money to purchase commercial grade licenses. Right, and so a consequence of this tight space, limited lab space and workstation space, and this growing enrollment, we have a crunch, right? And with the COVID pandemic, the crunch is obviously quite pronounced for us, right? So we're wondering what to do. Within all these things, we have the Fauda. The Fauda is us having to teach the core computer networks course to some small number n multiplied by 100 students every semester. And so in our MS program, we teach what I've put up here is the Mumbai University equivalent CSC 102 course, what MU calls Advanced Computer Networking Design. We call it Internet and High Layer Protocols, and I'm one of the program instructors for it. So I also designed the curriculum and set up the delivery structure for it. And so the last couple of semesters, we've had many hundred students every semester that have to take this subject before they can go on to take a cloud computing subject or a big data subject or a deep learning, machine learning type subject. So this is one of the what we might call foundation courses. So how do we teach this course, right? And this course traditionally has had a lab component, right? And the lab component, which is probably slightly different than an MU curriculum or for that matter, any other Indian college curriculum, involves a number of students that have to do work on either a research project, which is an implementation project, not just typing up papers and submitting it, but also a practical project in which they have to write code, build a system, and then sort of run some simulations and stuff like that. So that's sort of the problem. And of course, the problem is defined and maybe worsened by the limited lab space that we have. In addition to the limited lab space, we also have sort of limited network space. Right? So NJIT obviously has got very good internet connectivity, but in terms of IPv4 addressing space, we have 2 Class B addresses that were given to us many years ago. And then obviously we have some IPv6 stuff going on. But within the IPv4 address space we've been given, we're running out of space. Right, so we also have a VPN structure that lets students come in and get connected and so on and so forth. Still not enough IPv4 addresses. And as you might imagine, these things are heavily NATed down, right? So there's a bunch of different NAT networks inside that we need to work with. And now we have a partnership with the Amazon Web Services crowd. So Amazon Northeast is working closely with us. And so getting hardware and resources, etc., is not by itself a problem. But some of it falls into what I loosely call as the non-Google test. Right. So this is something as faculty we struggle with is we're always kind of struggling and evolving to come up with uh, technical projects of some reasonable technical vitality that will obviously reinforce some of the concepts from the texts and such, but are also non-Googleable, right? So we call it the non-Google test or the NG test. It's kind of similar to an NP hard problem. So I wanted to spend a minute on this. This is an odd kind of problem because we've got a bunch of problems that we can pick up either from textbooks and then flip them around a little bit and make assignments out of the projects out of them and so forth. But over the years, we've observed that the instructional faculty has to really work hard to make sure that these projects are relatively unique and that the solutions and such cannot be Googled. And so when we look into why this is the case, it's because of sort of these three factors, right? So many students, and these are talented students, even those from an NIT or an REC background, somehow seem to want sort of an easy way out. And somehow they're not motivated to do the projects and do the work and then and get next to it. I'm not suggesting that they're lazy or that they're not talented or anything. Quite the contrary, actually. They're quite motivated and talented. But when it comes to finishing up programming assignments, for some reason, there's some almost a natural tendency to go hit Google first. Sometimes some of it is due to a lack of sort of proper training in their own BTech curriculums. And then what we all know is a general shortage of instructional staff and so on and so forth. And this is not an India problem. So, we see this in students from China, from Europe, and from other places too. And third, this is a kind of an alarming trend we've seen is a number of students show up here in the United States and they all just want to be Sachin Bansal. Right, so a number of you probably identify with this, right? So everybody wants to be Sachin Bansal, the founder of Flipkart. And so when we interact with these students in classes, we find that these students have this type of mindset it's almost as if the tech part is a secondary afterthought to everything, right? So just don't worry about the technical part. Right? Don't teach me algorithms and systems and all these things. Don't teach me congestion control. Don't teach me pipeline protocols or anything else like that. Just tell me how can I put these things together to float a startup. And this puts pressure on us as an instructional staff that, hey, we're trying to teach you some fundamentals. We'd like you to be innovative. We'd like you to go found the next Flipkart or the next something else. But it's important for you to be able to actually do it and not just talk the talk. So summarizing these in simple words, our students from term to term are actually quite Jugaadu. Right. So we have to come up with ways in which we can handle sort of these large class sizes, convey the material in a 15-week semester, come up with technical projects and assignments that reflect the material and then challenge the students and engage them constructively. And in all of this, make sure that we meet all of our other metrics, right? So just like you guys as instructional faculty have to fill out reports, we do too. We have to fill out all kinds of reports on engagement and hitting all the right problem areas and all the rest of it, right? So we have to do this. So it's a difficult problem as it is, but when there's this Fauda due to COVID and spikes in students, it gets even harder to do it, right? So how do we typically approach this, right? So what we use is, to start with, we use the same text, and this is not news to you, right? So it's For computer networking, it's Kurosa Ross or Kumar or Furuzan or one of these other texts. I'm sure you guys use the same things that we do, all the standard text, right? So you guys know this. Kurosa Ross, the text comes with now these interactive problems and solutions on their website. So I put up a picture of a problem, right? And there's a problem asks questions of this sort. So they have these problems that are auto-generated. So Jim Kurosa, who's visited NJIT, we've talked to him a few times, etc. Right? So he had a couple of his students at UMass come up with these interactive exercises off of the websites, and the exercise is where it automatically generates some kind of network and then asks some questions about it. So traditionally, we've used question sets that are built on top of some of these type of exercises, but with some design twists in it and so on and so forth. Over the years, what we found is this turns out to be almost sort of rote learning, not deep learning. And students somehow get past these very quickly, right? So they do the pattern matching thing very quickly. And so this is not a scalable and effective way anymore, right? So we got to find some other ways to deliver something that's a bit more scalable, a bit more effective, and so forth, right? So we cannot use the text problems, right? We cannot use the supplemental problems. We need to come up with something that's a little bit different. So what did we do, right? So we looked at this whole problem, and plus we had to solve it fairly quickly because we have a few hundred students that we have to get through the program, and we don't have 3 years to sit and do research on this and so on and so forth, right? So we had to shift to Jugaad mode. Right, we had to do something that's fairly quick and also something that can scale and then create this platform, right? So we knew we had to do this fairly quickly. This became apparent to us in say mid 2020 or so, when we realized that this pandemic isn't going away anytime soon. And so we looked at the old model of learning, which went something like this, right? So there's the old model of learning. There's a text. There's website and other collateral, instructor websites and instructor solutions and all the rest of it. And then somewhere down the line is the learning. There's learning that comes with it. And what we did is we said, well, maybe we move the website and the text together, right? Bring them in here and put our little platform here. So there's a technical platform on which we can build these exercises and get students to work on some projects and so on and so forth, and focus on sort of student effort in tackling something that's on a platform, right? Not student effort in memorizing or pattern matching against something that's there on the website, right? So we had to get rid of this old thing fairly quickly, get to the new thing fairly fast. So we were looking around to see what kind of platform. And then, as I told you before, the limitations of our physical as well as our virtual network spaces meant that we needed to innovate on platform fairly quickly. So we shifted to VM, right? We moved a bunch of our existing physical resources into VM. And then we also began partnering with a company that would provide us sort of on-demand VM type of platforms on which we can build some of these VM workstations. So why are the VM workstations necessary? It's because we'd like to come up with fairly unique yet academically consistent examples of project networks that people can work on, right? So we didn't want to have the same assignment be presented to 400 students at once, because everybody knows what happens in situations of that kind, right? So we have a couple people who solve it, and then within a week's time, the solution becomes available to everybody. So what we did is we came up with sort of this master script that would automatically generate certain NS3 type scripts, which are still incomplete. And then they'd be different in terms of the networks they represent and so forth. but academically, the concept remains the same, right? So it's going to use the same routing protocols, it's going to use the same TCP dump tracing mechanism and so forth. But the actual network will be different, right? So a student in one section couldn't benefit from collaboration with the student in another section, right? We'd have some separation of duties there. So we wanted to do this platform. And so here's a quick overview of NS3D platform, right? So I'm not gonna go through this in great detail. I don't want this to be a tutorial on NS3, but just enough to get people to appreciate the background for this talk. So what's NS3, right? So in NS3, of course, NS3 is the next version of NS2, which is based on the real simulator from 30 years ago or so. And so it's a discrete event type of simulator. But for people that are teaching computer networks, right? So if you see a computer network that's represented here, in NS3, you can create a script to mimic this network, right? And this network has an arbitrary number of hosts and routers and switches. We can then feed it into NS3 and then run a controlled simulation. And NS3 outputs these traces, which you can read and analyze, some in ASCII and some using TCP dump. And in so doing, NS3 lets you create and simulate arbitrarily large and complex networks in software. And the software part is important because we all know that physical networks are best, and we've normally encouraged our students to run raw TCP dump inside of a controlled network and so on. But physical networks have their limitations. And even if you went into a physical network with a virtual box or a VMware type of configuration, it's burdensome to stand up 20 or 30 different VM images or stick a bunch of interfaces into existing VM images and so on and so forth. And when your goal is to teach networks, you'd like students to be able to come up with a network with 30 or 40 different hosts. And then from there, you can help figure out how to do it, right? So that's just a very quick overview of NS3. Okay, so this was our process, right? So the first version of the process, which we did in the fall semester 2021, well, spring 21 going into fall 21 actually, was we as faculty will come up with some sketches of networks, right? We'd use graduate students, TAs and such. And from here, we develop a bunch of NS3 scripts with some gaps in them, right? So either we don't have routing rules properly in them, we don't have sufficient number of hosts in them and stuff like that. And then we'd hand these scripts off to our student population, and they would go about filling in the gaps and running it and debugging it and producing the output and so on and so forth. And then coming up with a report and a diagram, which we would grade and give back to them, right? So this was the process here, right? So each student group, each section, about 50 students or so, would get a script that describes a network, and different sections would get different such scripts, and they'd work on it in small groups, 3 or 4 students. And then they would produce the report and the diagram using NA, which is NetAnim, which lets you animate a network similar to what you see in the top left corner, and then come up with a diagram that we would grade. So we did this process spring of last year, going into fall of this year, and that's when some other things became kind of clear to us. And that, I think, is the greater learning, right? So the technical stuff is relatively the easy part, right? You download the software, it's all free, and then you play around and get some scripts together and so on and so forth. What we discovered was the tech part is the easy part. It's the other stuff that goes along with the tech part that's harder, right? So we sat down as a committee and analyzed this, and then did a bunch of surveys and stuff, and then came up with this new process in some of it is fall of 21 and some of it is this semester right now, spring of 22, where we realized that in addition to this technical process, we have to have a supporting structure or some sort of a supporting process. And here I'll digress for a moment and sort of channel a little bit of our Bharatiya Sanskriti here. So we all know that as human beings, in order to be able to perform at our best, we have to have certainly a reasonably strong physical constitution, right? We have to be alert, active, and so on. But our history also tells us that we need a dose of yoga, right? Because along with our physical body, there is this chakra body or an energy body. And we need the chakra body to be in alignment with the physical body. Right, so the same principle is applied here, and it's also one of the reasons I'm happy to give this talk at an institution that bears the name of Swami Vivekanand ji, who was a champion of this cause. So we need to support this technical process with a number of these other processes which are represented here with the pink brain icons, right? So this icon, for example, is a pink brain icon, right? So number one, we discovered that we need an entropy mechanism. Even though we came up with different scripts for different sections, students were coming fairly quickly to realize the patterns that we didn't see, right? So when they saw an arbitrary network of hosts and routers and so on and so forth, they would catch the patterns fairly quickly. And we realized this is because we started with a network that was provided by the authors of the textbook. Right, so whatever variation we came up with here to this network directly into our scripts wouldn't work. We needed to bend the network in arbitrary ways. And so that's when we took the help of a company that's based here in New Jersey that also does Cisco network training and so on. And so they gave us a couple of engineers. We paid them a little bit of money for it. And they were able to take some of these and produce almost non-isomorphic networks that would be different and that would be sufficiently different that students would have to spend a little bit of time. So we realized that we had to do that. The next thing we realized is not all students have the same learning curve, right? So when we came to do our assessments and things, a number of students complained that they'd never seen NS3 before. And this was surprising to us because NS3 is, of course, it's widely available and there's a lot of support for it and so on and so forth. But somehow to level the playing field, it's necessary that all students have sufficient resources to be able to play with NS3 and to be able to operate these scripts and so on and so forth, right? So we did a bunch of searching and we found a number of people that are offering tutorials in NS3 and so on and so forth. And so we started giving our students pointers to some of these YouTube videos. So some of you might be asking, well, great, you give them pointers to these videos. Why don't you produce them yourself? So the answer to that is, guys, remember we were in a Fauda, right? We got 500 students. We simply don't have the time in the middle of a 15 semester course to go produce YouTube videos of our own for scripts that have entropy in them. And so we have these arbitrary network configurations coming out of our scripting engine. We don't have time to sit and do YouTube videos and so on and so forth. And then, of course, the other questions that our faculty board, etc., asked us, so why don't you use students? So the answer was in the summer of 2021 going into, or the spring of 21 going to the summer of 22, we were still all working remotely. So it wasn't possible for us to to be able to produce videos that would address some of these type of gaps, right? So, but we do realize now that we need to have something. The third thing we realized still here is the existing videos on the internet. They're produced mostly by people that explain the scripts that come with the NS3 software itself, right? So if any of you are using NS3 or NS2, you'd know that NS3 comes with a few different basic models: first model, second model, CSMA model, Wi-Fi, WiMAX model, and so forth. So the existing YouTube videos describe how to build networks that are almost identical to the networks that are, that come with the software. And so those are no good, right? Because if you go through some of those, they don't let you discover what happens when you have these arbitrary type of network configurations, right? So we need some other ways in which we can train them. So then we filled the gap a little bit by having some of our TAs and stuff, but still that didn't scale. So we're still trying to wrestle with that. How can we boil it down into some conceptual thing, and what can we do with it? The third thing that we weren't prepared for spring of last year, but we got a little bit better at it in the fall of last year, was debug and crash assistance. And so a lot of students, when they were sort of completing some of these programming assignments, found that their network scripts were failing and crashing. And it sort of helped us in the NG part of it. I mean, they couldn't go Google or search Stack Overflow and stuff like that for a solution. But at the same time, they didn't know how to debug it on their own, right? So they didn't know how to, for example, complete a CSMA container channel that we deliberately omitted between two routers, right? So packets weren't getting through, and after a while, the network would crash. So we discovered that we needed to get some debug and crash assistance. And here again, we went back to this company and we said, look, why don't you give us 3 or 4 people on retainer, create an 1-800 number that students can call them, and so on and so forth. So the company helped us out, but we're quickly realizing that that's not scalable for us. I mean, we're not able to really sustain this type of a model. So we need to do something about this part. And then finally, for our faculty members, we need some kind of rapid grading guide, something with which they can grade some of these very different scripts consistently and give specific and actionable feedback to our students. So this was a huge learning for us last semester, is that we got the technical part kind of sort of right, but to make it effective, we need almost this neural network type thing, if you will, that needs to align the process part and so on and so forth with the technical part, right? So we're still working at it. I mean, we're not completely there yet, but we'll see how we do. So what are some of the lessons learned, right? So the next steps are to realize some of these things. The gaps exist, right? So there's all kinds of gaps in computer science education. There's a gap between the text and the teacher and the student, the text and the student. Second thing is tech is one part of the solution. We need these other parts, the process part, the training part. And the training part is not limited to just students. Of course, we recruited aggressively for lecturers and senior lecturers and stuff like that at NJIT. Still, what we found is not all, even networking PhDs, are necessarily familiar with something like NS3. Some of them have done pure simulation type of research work. Others have done pure measurement type of research work. Others have done really industrial focused congestion avoidance and congestion, that type of research work. And some people are very specialized. There's a lot of buzz these days on 5G. So a number of guys are doing 5G type of research, right? So they are not all on the same platform, and many of them are only sort of superficially familiar with something like NS3. And then that's just a function of where they did their PhD work and what type of work they did and so on and so forth. So we have to focus on this other part. Third, it's very clear to us that US universities need to have a broader academic partnership. As an academic partnership, a networking partnership, a social partnership. That also includes faculty talking to each other, right? So stuff like this that you guys are doing is very helpful because it helps bridge this gap between the supply function, which in technical education in the United States is still largely India, and there's some China, some other things, largely India, and then the demand that's in the US and some of the other countries where some graduates go. And so some previous preparation or prep in India, it looks like is going to be necessary in the future. A few years ago, I had the good fortune of having some interaction with Nupurji. I'm not sure if she's on the talk right now, but it was one of the things I was talking to her about in terms of
Yeah,
how
I'm
some of
there,
the.
sir.
Hi, Nupurji, how are you?
I'm good. I'm listening to
Good,
your
good,
talk, sir. Yeah.
good. So it's very clear to us that we have to have some broader partnership here as we go forward, right? And then of course, tech transfer, enablement, feedback, learning, etc., are required at all levels, right? So we're looking to expand this offering and socialize it to some of the nearby institutions, Rutgers and Penn State. We've begun to have some discussions with them about how we can use this. They're obviously very interested because they have a different problem. Penn State, for example, in University Park, Middle Pennsylvania, is they're trying to restructure some of their engineering curriculum, and they'd like to have a consistent offering everywhere. Right, so they have this problem where they have new faculty, they recruit aggressively, and they'd like all of them to teach kind of a common curriculum, right? So we're looking for something. So we're looking for students who can help with these things and then go on. Finally, some really step back and blue think kind of observations, right? So I think I'm preaching to the choir here because a lot of you will very much agree that computer science or computer science and engineering education is hard. And it's not hard because it's students and teachers. We've come to believe that it's hard because it's a multidisciplinary subject. And multidisciplinary doesn't necessarily mean multiple parts of computer science, as algorithms, analytics, networks, and other things. It's also because we have to be aware of the psychometric part, the psychological part, the student motivation part, and the technical part. And then the student motivation part is a particular issue because when I think back to, when I completed my undergraduate degree and so on, there were students who wanted to innovate, and I certainly went to industry and worked in industry for a number of years. But there was still some sort of connection to fundamentals. These days, we have found, and I'm sure some of you might have found as well, is everybody wants to just be a Sachin Bansal or a Ritesh Agarwal. People seem to be very uh, impatient to achieve, fame and fortune and all the rest of it, and they almost view engineering as, हाँ यार कर लेंगे, हमसे नहीं होगा किसी और से करा लेंगे, हमें बताओ कि इसका हम बेचेंगे कैसे, how can we sell this thing? And that's really not a computer science problem. It's something that we're burdened with, but we need to tackle it. And we need to gently mentor the students, bring them back to this idea that even Sachin and Binny Bansal, at the end of the day, are both IIT graduates. So merely making noise and creating apps and video games isn't all of it, right? So sort of a baseline technical education is necessary. Secondly, we've there's a lot of flipped classroom type research going on, and you guys are well aware of this with NPTEL and MHRD India initiatives and so forth. But still, there's a large number of students whose goal in life somehow seems to be to achieve Coursera, Udemy, Edureka things, or badges and credentials. Somehow everybody wants to chapify a few papers or get badges and credentials and become famous as quickly as possible. So somewhere something is off. We need to address this and figure out what it is. And now there's a bunch of innovation in learning management systems. So you guys probably use Canvas Moodle type of thing. And so, there's some innovation there. But that's learning management innovation, right? Not necessarily sort of educational innovation. And so this is pointing us, all of us as educators, towards this one problem, that you need to have these evolving problems or these evolving platforms which generate some of these problems to challenge our students, right? So not just manage the education delivery, manage the classroom, and provide additional content, but we need to come up with sort of these interactive exercises and stuff. And we need to do so with a focus on sort of technical education, not gamification. So there's a couple of startups in the United States that hope to gamify everything. Okay, so evaluate an algorithm properly and you get game credits. So we need to go away from that model, right? And finally, it's not money can't buy everything here. We need the right combination of skills, money, tech, and such to scale it effectively. Like a computer security type problem, it gets tougher with time, right? So students are obviously Jugaadu. So we need to be even more Jugaadu as we go along. So that's really it, right? So that's, I think I went on for 5 minutes more than I wanted to, but let me pause here and let me take some questions or comments or other observations. Richard, back to you.
Yes, sir. Anybody, any questions? So I would like to specifically ask, like this model that you're thinking about, okay, could that be applied on other domains as well?
Oh, absolutely. You mean to say other domains as in other subjects in computer science, algorithms, databases, and other things?
Yes. Sir.
Yeah, so the database folk are particularly interested. I think you might want to ask, when you invite Professor Murli sometime, you might want to ask him this question as well. Because for us in networks, the platform is NS3 and NetAnim. Right. So this platform could very well be any kind of database, Postgres, MySQL, whatever. The problem there, Richard, is many database courses just say build a library management system, e-commerce system, auction system. So this open-ended thing isn't going to, I think you have to go to supply chain or implement a blockchain type structure over a relational database.
Okay.
So something of that nature. So yes, the model is applicable. It just has to be, you have to think it through.
Okay.
Algorithm is again, right? The other thing is in our, we teach data structures and algorithms. So algorithms, no single platform exists for this. Right? So you can't have students evaluate, a red-black tree versus a B tree or a B plus tree. So
I guess Nupur ma'am has raised hand. Yeah, Nupur ma'am.
Hello, sir.
Hi, Nupurji, how are you?
I'm good. Sir, I had a couple of questions regarding what you spoke about, the standardization of the courses, which I think so you all are collaborating with Penn University and other university, and then they are looking out for some collaborative work once we reach as you said, this Jugaad thing and the VMware, and come up with let's say some kind of a virtual lab kind of a setup. So are they? Is there this sort of consortium formed on a, uh, or are you planning to, collaborate with universities and we form a? Because what the reason I'm asking is, though the problem really looks interesting, and I think so there would be some faculty and teachers would be really interested in working on this. In India, our problem is the infrastructure के लिए funds. Like, we can give time, but we don't have funds. So if there is a consortium which has already been granted the fund for all this, we may look into the problem, sir, because it's a problem everybody is facing, not only you know uh, our
Yeah,
problem is funding.
yeah. So, so Nupurji, this is taking us back to the discussion that we had when
Exactly.
you and Shaluji were kind enough to show me your labs and infrastructure. So, a consortium is being worked upon. It's not slated to be ready until probably mid-year next year. Okay, and that's because, see, as I said, in this case, we had to use our own sort of funding to go
Hmm.
pay this company. We actually paid
Mhm.
this company in New Jersey to develop it. Now,
Mhm.
the funding is not just for hardware. See, the thing is that these are, the infrastructure for this is to get, something like uh, VMware, ESXi, etc. To support 1,000 students roughly is not that expensive. The infrastructure itself is probably $2,000 maximum. Right, so that will be 1.5 lakhs or thereabouts. So that's not the big part. The big part is getting this vendor to scale it.
Yeah. Mhm.
So they charge per seat, as you know.
I know.
So see, now in India, actually, in a couple of our faculty, we were looking at this. In India, you have companies like Big Rock and a couple of others.
Mhm.
But these things run out of gas the moment you cross 200 odd users. So I am deeply aware of the problem that you are you are stating. Alas, at the moment, I don't have a solution for it.
Mm.
But yeah, as long as we come into something that we can see
Yeah.
what to do. Yeah. But I'm curious about another thing, Nupurji, is that in your case, or let's just call it in the case of say Mumbai University,
Mhm.
um, is there some assistance from the state level or from center level that might make
Yeah. That is
2
what
lakh,
was the
5
next.
lakh available?
Yeah. So, sir, that is what I was about to talk. There are some grants available in collaboration with foreign universities,
I see. Okay.
right? So if that is what when I said whether the consortium is already formed or a proposal could be written for getting the grant and then maybe work on it, so that is a possibility, sir. So I will send you the links of those grants. Let's have a look at it. Then collaboratively, if we
I
want
would
to,
very much welcome that,
I
Nupurji.
will
I
I
would
will send you
absolutely
the
welcome that.
I will send you the
Welcome.
links.
Welcome.
Yeah. Yeah. Yeah,
Richard,
Richard,
I think
over
Yes,
to
it's,
you.
yes, yes,
yeah,
sir.
back to you. Are there any other questions from anyone? I mean, if there's other faculty that are teaching, 6.15 in MU terminology, undergraduate computer networks and so on, I'd certainly be
I guess we have a computer network faculties here. Uh,
okay.
yeah, we have Prashant sir. He has raised his hand.
Thank you, sir, for your introduction to NS3 and all efforts you are taking. The one problem I face one issue really while teaching this computer network, that students who were up to 2015 were okay with taking efforts to solve the problems. even if take example of cyclic redundancy check. But now students are not very much happy to solve such problems. Even network addressing problems, they are facing difficulties. And so what we can do with this kind of thing, because they are not at all taking efforts to solve such problems. Because
No,
when
Prashantji,
we, yes,
this is a very important question, and this is
yes,
precisely why I'd put up this slide here.
yes.
So have you parsed that problem? What is the reason? Is it they don't have the proper knowledge how to do it, or they want
No,
to?
I think they are very much interested to get a ready-made content. That's the thing. Because
Yeah.
and we know I used to tell them, I often while solving or while teaching that particular problem, we tell them that this problem will definitely, or this type of problems are definitely going to appear in your exam, but still the same mistakes they are doing. So this is since last 2, 3, or 4 years, and they want, okay, is this coming in exam? Then only we will solve it. So they are very much marks oriented, not skill oriented. So if this
Yeah.
kind of tools are made available, then definitely that will be a great advantage.
I agree with you, Prashantji. I think the problem
Yes.
is unfortunately above your and my pay grade that
Yes. So we have to
university has
create
to. And
interest.
yeah,
That is the thing.
yeah, yeah. And this other thing, see, the other discussion that goes in here is again in my previous visit to Vivekanand when I was having, a discussion with Viji ma'am
Yes.
and other faculty members is exactly this issue that autonomous versus university directed.
Hmm.
So when exam is coming from say university direction, and then the student's mentality, rightly as you said, is just tell me what is on the exam. Why should I
Hmm.
lift heavy weights to complete any lab? Right. And
Yes.
yeah, that
So
is
that is
a M.
if we
Yeah. So
create interest,
yeah,
interest building kind of platform, then definitely they will enjoy. That's
I
the
think
thing.
so. I
The
think
need
so.
of
I
time.
would.
Yes.
So my short answer to this is not to you, Prashant ji, but actually to Viji ma'am and to Nair ma'am, which is that get autonomy as soon as possible.
Okay.
Then we can do this the right way. See, for me, the advantage is that we are an autonomous institution. All US universities are autonomous institutions. So the day you get your autonomy, then I can pass along my scripts and everything to you, and you guys can teach it the way it was meant to be taught. But as long as you
Okay.
have that
Yeah.
uh,
University directed curriculum.
direction, then okay, we have to go with the thing. But I understand that problem very deeply, Prashant ji, because a lot of the students come here with that, right? So in our case, 50% of the course evaluation is the group project.
Okay.
I have got that power that you cannot escape the lab. You must do this. If
Hmm.
you don't do this, then you cannot graduate. Right. So I I wish I had a better answer than that, but that's kind of what I have right now, Prashantji.
Okay. No, no, not the, we will definitely try to get better approach for this.
Yeah.
Okay.
Richard, over to
Yeah,
you.
yeah,
Other
yes, sir.
questions?
Yes, sir. Sir, like there's a question from my side. Now,
Hmm,
as we talked about, students facing this problem with the depth, the knowledge.
hmm,
So you implemented this model wherein you saw to it that students have to kind of get into it no matter what. How
hmm,
they're like you're ensuring that they go through it. Now, for various subjects that we have, like DBMS or any other, okay.
hmm,
The thing is like we are following the university model. We are having a certain structure to follow, and we have our assignments and things like that. Okay,
hmm.
so like we would be really happy if we could get to know more about uh, the assignments or the things that has been floated in your universities, okay, which we can help to challenge our students.
So, I mean, I'm happy to collaborate in a limited sense on that, Richard. But I think you'll have to first get through the problem identified by Prashant ji a minute ago.
Sure, sure.
See, even if we pass along, incidentally, Richard, this is a fairly long discussion I had with Shalu ji and Nupur ji, as well as limited little bit with VG ma'am also. That yeah, you are under university system, so I could give you all the assignments, but again, right back to Prashant ji, students will say, sir, don't give me this bol bachan, just tell me exam में क्या आएगा, हम उतना ही करेंगे, ये बाकी चीजें हम बाद में सीख लेंगे, सेल्फ स्टडी कर लेंगे, आप इतना बता दो एग्जाम में क्या करना है.
Right. Yeah.
So unless you break that in some way, then we can do. I think if I think Nupur ji has another comment on this. Did I just see her hand go up again?
Nupur ma'am? No, I guess it's up.
No, yeah.
Since some time, yeah.
Yeah.
Okay, so I guess does anybody has any other question?
I guess we are done.
Okay. Can we start with the closing ceremony?
Yes, for sure.
Richard, I think so. You have to take the picture, right? The video for attendance.
Yes, ma'am. Video is already getting recorded. I'll ask everyone to switch on the cameras and then we'll take yeah. Everyone, I please request everyone to switch on the cameras so that we can take a group photo. Yes, everyone, kindly keep it on for a second. Yes, ma'am, I've taken the pic.
Yes, sir.
Yeah.
Richard, could I get a copy of this photograph, please? Whenever you.
Sure, sir. Sure, sir. I'll send it to you.
Thanks.
Thank you. Thank you, sir. Thank you.
Ma'am, we'll have the closing ceremony, and also everyone, a link has been posted in the chat box. That is for the feedback. So kindly give your valuable feedbacks over there. And yes, Amit, we can conclude the session, please.
Yes, for sure. Can we have the certificates in front?
Yeah.
Yes, sir. Is it visible?
Yes, ma'am.
Yes, ma'am.
Oh, that's so beautiful. Thank you so much. So nice.
Shall I start?
Yes,
Sorry,
ma'am.
go ahead, Amit.
Yeah. So on behalf of VESIT, IQAC, and Research Forum, in association with Institutes Innovation Council, IIC, I, Amit Chabria, from Department of Computer Engineering, is honored to give the vote of thanks for such inspiring talk of Fauda Jugaad, online teaching prodigy, Pedagogy, by Professor Kumar. It has been very encouraging. All of us present here, but we are also thankful for the Professor Kumar for taking out his time from his hectic schedule and to give us and to enlighten our knowledge with wonderful jugaads. I would also like to thank our principal Dr. V.M. Nair, and our vice principal Dr. Vijayalakshmi, and Dr. Nupur Giri, HOD of our computer department, engineering, and Dr. Nupdesha Bhatia, ma'am, deputy HOD of Department of Computer Engineering. Dr. T.M. Patel, head of Research Forum, for whose initiative with this would have been taken. I would also like to thank all the VESIT staff and scholars on being present and making the event successful. Participants are requested to fill the feedback form that has been shared in the chat. Thank you.
Thank you so much,
Thank you
Amit.
so much.
Thank you, Kumar sir. It was really great, and we really enjoyed your session. And I hope we move forward in the direction that you have suggested. And we also want our students to go deep and not just become one Sachin Bansal right away, actually.
Well, I'd hope you'd like them to be Sachin Bansal after they
Yeah.
have the necessary technical training and
True,
everything.
true, true. Yes, sir.
Okay. All right.
So-
Thank you all. Good night. Take care. Keep in touch.
Sure, sure. Thank you so much, sir. I'll be in touch with you.
Thank you, sir. Thank you.
Yeah.
Thank you, sir.
Ma'am, we can stop the recording.